Intro Algebra Lesson 4-4B. Alright, last time we introduced the concept of slope. So we've now been taking all these linear equations, we've been looking at input-output tables, we've talked specifically about x and y intercepts and how to make a graph, and now we've looked at the parts of a graph, mainly the slope. Alright, so keeping with this theme of slope, we have the concept of the rate of change. Now, the rate of change in a real-life situation is going to compare two different quantities that are changing. So our slope is actually a rate of change because it's changing in rise over run. So it's going up or down, which is a change, being compared to the left and right change, a rate of change. All right? If I were to say that the current population in Junction City is 10,000 people, then if 10 people move in every single month, the rate of change would be it's going up by 10 per 1 month. If it's going down at 5 people per month, then the rate of change would be -5 per 1 month. But it's still two different quantities that are being compared. That's the rate of change. So here we have a hard situation. We've used the slope formula already to solve for the slope. But in this case, the slope is given to us and we are missing part of a coordinate. All right? Now I'm going to make a suggestion when you're doing this. Whichever part you're missing, so in this case this is the coordinate we have something missing from, make that one the one that has your sub 2 values. So what I mean by that is label this as x sub 2 and y sub 2, x sub 1, y sub 1. And I know that last time I mentioned that it would be a good idea that the first coordinate is your x sub 1, y sub 1. It really doesn't matter which one you label as long as it's consistent. So the two sub-number 2's are here. The two sub-number 1's are here. X and Y. X and Y. That's really all that matters. I'm suggesting you make the y sub 2 the unknown because that way when you go to solve, it'll be easier for you. All right? Our equation, our formula, would state that m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now out of this information, we know this number, and that number. The only one we don't know is y sub 2. So we substitute everything we do know in. So I will have the slope is -2, and then that's equal to the line with the two subtraction signs. My y sub 1 value is 5. My x sub 2 value is 3. And my x sub 1 value is 1. And what I don't know is that value right there. But I can simplify and I can solve. So I can do 3 minus 1. I can change that to plus negative. And I end up with -2 is equal to y plus -5 over 2. And I need to use inverse operations to solve for y, to get this alone. So what I'll do is I'll multiply both sides by 2, because that will cancel out the 2's. What I do to one side, I must do to the other. So those 2's cancel out. That becomes -4 is equal to y plus -5. One step away, I add 5 to both sides. I have one more positive than I do negative, so 1 is equal to y. And if you go back up and test it, go ahead and stick 1 right here. 1 plus -5 is -4, and 3 plus -1 is +2. If you had -4 over +2, it would equal -2. So we have it. That's the correct answer. That's a little trickier than the regular slope form because you have the slope and you have an unknown piece of a coordinate. I would recommend that you always make the unknown part have the sub 2 numbers. It makes it a little easier for you. Alright, next we have this example which is almost the same exact thing. I'm still going to label this as my sub 2 values because the one that I don't know is what I want to label as my sub 2's. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And out of this information, I've got the slope, I've got a y value, the x sub 2, and the y sub 1. I do not have, or the x sub 1. I do not have the y sub 2 value. My slope this time is positive 2. And the slope is always equal to a line with two subtraction signs. So my y sub 1 value, I just mislabeled this one, y sub 1. My y sub 1 value is 5. My x sub 2 value is 2. And my x sub 1 value is 4. The part I don't know is right there. That's the unknown. And then we just have to solve. It takes a couple steps. Plus negative, and I end up with 2 is equal to y plus negative 5 over negative 2. Multiply both sides by negative 2 over 1 to cancel out that negative 2. And you end up with negative 4 is equal to y plus negative 5. Add 5 to both sides. And 1 is equal to y. So the piece that I'm missing is a 1. If you test it out, 1 plus negative 5 is negative 4, and 2 plus negative 4 is negative 2. And negative 4 divided by a negative 2 is a positive 2. So it works. Alright, last example. Find the slope of each line. Now there's a couple ways you could do it. There's two different lines here. One's red, one's purple. You could find coordinates on the graph, and you could say, here's a coordinate, and here's a coordinate, and you could use those two coordinates and one of our slope formulas that we've done here, something like that, and you could find the slope. Or, what's easier when you have graphs is to just count. Say I go from this spot to this spot. I've got to go down to get there. I've got to go down 1, 2, 3, 4. And I got to turn to the right 1, 2, 3, 4. Which means the red line, the red M, is equal to negative 4 over 4, which is the same as negative 1 over 1, or just negative 1. Okay, the purple line, find two coordinates on the purple line that look pretty good. Doesn't look too good right here. I do see one right there, and maybe one there. So it looks like it's going left and down. It goes left 2, which is a negative, and down 2, which is a negative. So for the blue line, or the purple line, purple slope is going to equal a rise of negative 2 over a run of negative 2, which is exactly the same as 1. Remember what we talked about last time? If you look at it from left to right, it's going up, so it should be positive. And if you look at it from left to right, it's going down. That would be negative. So this is clearly a positive slope. That's a negative slope. If you want to write negative 1 as a fraction, you put negative 1 over 1, so you have rise over run. If you want to write 1 as a fraction, you just write 1 over 1, which is no different than just 1. So we can use slope on the graphs, or we can take slope from a graph, or we can actually use coordinates to find slope. Either method still comes up with the same value of slope, rise over run.